evening all. Oh, music's a bit loud. I trust we are all well. Yes, we're going to be doing a bit of refueling tonight. I've been looking for something we could do that would kind of be a quick win, so hopefully we can get all of that done in 4 hours, which will be interesting. Hello, hello. Very true, AJ. Yeah, fortunately we're taking our fuel from source, so nice cheap fuel. So normally I'd go and show you what I've been working on for the past 2 days, but it's mostly just been bug fixing, so there's not much to show. However, what I have done is I've started porting our bug tracker across to the new website. So we've already got the old tickets transferred across. We don't have a page yet for looking at them, but this should transition over hopefully reasonably soon. So we'll change the in-game bug ticket page to start sending bugs here. And if you are registered on the website, then you'll be able to start upvoting various tickets depending on which ones are the most important that you think we should fix. So that should help our workflow a little bit. Basically, we got 112 bugs now, I think it was, at the last count. So I'm just looking to streamline the process a little bit so that we can get through them quicker and manage them easier. But no, other than working on that, it's mostly just been bug fixing. It tends to go like that sometimes when we're kind of working towards a release. Yeah, actually on that note, one of the things I changed was the logic on our little Roomba guy. So what was it I had him doing? He was doing something different where rather than just picking the most grungy floor and going there, he was waiting until there was something that had that amount of grunge on it, which meant that things were getting dirtier too quickly. Yes, we've got our linger delay there, so we'll keep that. Yeah, so we're getting all of the dirty floor tiles, and then we're grabbing the grunge level on each one. We're adding that to our list of targets. Yeah, and then we're going to a random one. And I think this is what's happening. So because we're going to a random one each time, we're not going to the dirtiest one, which means some of them can get missed in the random selection and just end up being really, really dirty. So if we get rid of the random, we sort the array so that the dirtiest one's always at the top of the list. And then what we can do is we can just get the first element of the array, which is always going to be the dirtiest tile, which means that the Roomba will now prioritize the dirtiest tile on their deck. I have to make sure that the logic works for multiple Roombas working the same deck, because they're all going to constantly be crowding towards the same tile. So I won't do it yet, but we'll add a claim to this. So If one particular Roomba says, right, I'm going to go and fix this particular floor tile, then they need to be able to claim that. And the other Roombas won't try and fix it because it's already being dealt with. So that's just a little bit of an additional logic we'll need to add to that. But that should fix the problem with the carpets building up dirt too much. There we go, problem solved. It does actually. So when the Roomba's moving around, it's constantly cleaning whatever is under it. So on its way to the dirtiest tile, it will clear a path along the way. It won't linger on each one to make sure they're fully clean, but it certainly cleans them as it goes. And yes, always put cream first on a scone. I don't know what those Cornish types are up to, but why would you put jam on it first? I mean, you don't put jam on bread before buttering it, so why would you put jam on a scone before putting cream on? Makes no sense. Yeah, you butter the bread and then you put the topping on. Cream is essentially the butter for a scone and the jam is the topping. So why would you put the topping on and then the undercoat? Yeah, these are the serious issues that must be debated. We had a cream tea this afternoon, so that's kind of where this is coming from. Oh, I've never made a quiche, so I wouldn't know. Right, so what are we doing? Refueling. So we've got two engineering stations here, propulsion and power. I think I was going to swap them around, and I can't remember what my logic was at the time. But that one's propulsion, that one's power. I think I might... It's like, which one's easier to talk to from this perspective? I mean, they are much of a muchness, but I'll leave them as they are for the time being. But what we want to do is on this one, because it's the power systems one, this essentially needs to be a reactor diagram and all the consumables for the reactor. So if nothing else, we need fuel tanks on this UI. I probably won't have time to add all the reactor readouts and stuff tonight, but we can certainly put the fuel tanks on there and the fuel level. And then what we'll do is we will have a simple button that just says begin refueling for now. Obviously we're kind of crowbarring this in quickly within our 4-hour slot for the stream. So it's going to have to be a case of if we are within a certain distance from a gas giant, and we won't worry about gas giant class for now, but if we're within distance of a gas giant, then the refueling button will light up and you can refuel the ship. If you fly away too far from the gas giant, the button will go away. I think that's probably the easiest way of doing that. We'll do it from orbit to begin with, and then we'll have a look at whether or not the NPC can successfully skim the surface a little bit. Might also add some tessellation to the gas giant surfaces. Now that Epic have fixed some of the tessellation issues, we should be able to do gas giant clouds in 3D just via tessellation, just kind of fake 3D, just to give the surface a little bit more texture. They will be volumetric at some point, just not yet. So once we've got the ability to refuel from this console, we then need to have a think about the captain and some kind of a state check on the ship, because I guess the ship's computer needs to track various aspects of the ship's health, and status of the fuel tanks is kind of part of that status check for the ship's overall health and fuel supply. So if the commodities are running low and they breach a certain point, then the captain NPC needs to essentially stop whatever's happening, so kind of belay any orders that are currently active, focus entirely on refueling the ship, and then continue those orders that have been paused. So kind of that's our plan for the evening. So really, I guess the first thing we need to do is get the readouts visible on this screen, make the refueling button work from anywhere, and once it's working from anywhere, then we'll start restricting it to the range of a gas giant. And when that's working, we'll then start feeding that into the captain, because at that point we can have the refueling valves off by default, so that the ship can actually be refueled properly. So let's get started by grabbing a reference to the UIs in the coolant room. So we want oh, this is the wrong ship. So open up the right level. Basically, yeah, we're recreating the process from Stargate Universe, except not with the star. Possibly Delta. I think generally refueling is going to be chief engineer. So once the captain or the XO, whoever's in charge of the bridge at the particular moment, once they state the fact that the ship does need refueling, then that's going to be handed over to the chief engineer, who will manage the refueling activity. Because as much as we've got valves here that need to be opened to refuel the vessel, in the long run, of course, we've got these rooms down below the reactor, so you can't see them very well because it's all kind of grey boxed, but you got this room up here which is going to be the refinery deck. So we'll have our little refinery mining shuttle there and all the various storage things for the stuff you mine. And then down here on this level, this will be the fuel scoop hardware and all the kind of the intermediary tanks. So this is basically just going to be all pipes and ladders on this deck, and obviously underneath you've got the main shaft going down to the FTL ring, and we're going to have that kind of Star Wars style shaft of death going all the way down that you can look down. So there won't be a central walkway. We'll do like a circular either the spiral staircase or just gantries that go down, and then one solid reactor feed going all the way down the dorsal fin, feeding out to the capacitor banks that will be all the way down here, and you'll see them on the outside of the ship here. It's like heat sinks all the way up. So that's going to be exciting when we do that. But all the pipe work and the hardware essentially is going to be about here. So where are we? Front of the vessel. So if we pretend that this is the front, so we can see the decks. Where are they? There they are. Yeah, so the fuel scoop's going to go here at the front, and the hardware on this deck is going to be essentially gas filtering hardware. So the fuel scoop can be configured to suck up different gases, and the way we're explaining that in our kind of science and tech for the game is that it creates like an electromagnetic funnel out the front of the ship, which is attracting certain atoms but not others. So it kind of rejects some attracts others. So the configuration for that happens down in this room. So the hardware will specifically target, say, helium-3, and it will only attract helium-3 into its like EM funnel that it broadcasts out the front of the ship. And then all of that gets filtered into kind of temporary storage tanks before being pumped up into the actual tanks, which are these ones here. So these pipes that are coming in from here will run around the maintenance tunnels and then down through the floor into the area underneath. So we'll probably have the pipes kind of running up here, running up that slope into here. So there's a bit of rejigging and pipe work that needs to be done for this, but for now, obviously we'll just have it happen by magic, because we've got our magic fuel supply balls here. So these are like an infinite fuel source. So we'll have these be the proxy for the fuel scoop for now. But yeah, but then that pipe work does need to go down through the floor onto this deck at some point. Yeah, so the chief engineer and the engineering crew will be the ones walking around actually configuring valves, and probably via the engineering control room once it's in place, because all those valves and things will be remotely configurable from the control room, so you won't necessarily need to go and do it in person, but all that needs to happen in engineering. But the actions are triggered from the bridge. So we trigger it from here, and then it all kind of filters down into the engineering section. Seeker, yeah, the reactor will overheat if you have it on more than 100%. So you can stick it up to 110%, but it won't last long. It does get too hot quite quickly. Yeah, we'll dig into that PSV when it comes to it. So for now, the logic or the rationale of it is that we have a big funnel, like the front of a red dwarf. Why can't I find a picture of one? Yeah, red dwarf. So I don't know if anyone knows this, but in the red dwarf lore, this big scoopy thing out the front of it is supposed to be a fuel scoop. So as red dwarf is flying through space, it's constantly sucking up the interstellar medium, and that's what's providing fuel for the ship. So what we're doing is we're recreating what red dwarf has, but via an EM field. So it's not going to be a physical thing that extends out. It's going to be a field that we produce that basically does the same thing. So we'll have our collection hardware, like the collection nozzle, and that will extend out a field. We'll probably do some kind of really faint graphic to kind of indicate that that's happening, like a little sparkly something that shows that it's active and actively scooping. But yes, basically we're creating an electromagnetic version of this thing on the nose of red dwarf. As for the separation of the different chemicals, I guess we're kind of hand waving it a little bit by saying that we can attract certain elements that are free floating in gas giant atmospheres, But if more science is needed on that, then we'll roll that into the actual hardware itself. So beyond the nozzle of the collector, we'll have hardware which can spin or accelerate or do something to separate the different elements. And I'll be doing the pipe work when I do the lower decks underneath the reactor. Not anytime soon. I want to get the bridge stuff done first, and then we'll move down to C deck and start doing all the science gameplay. So once the bridge gameplay and the science gameplay are reasonably solid, then I'll move down through the ship and we'll start working on some of the more grungier stuff in engineering. Yeah, I mean, we could have a particle accelerator running around the ring. I mean, the geometry's there. We can also use that structure for other things, but I imagine we'll do it a lot smaller than that. So we'll, if spinning or acceleration is needed to separate gases, we'll keep that hardware down in the fuel collection room, just to keep it all in one place. Eventually, Kaji, yes. So once we have finer control over the chemicals of a gas giant, because right now it's just how much hydrogen does it have, how much helium does it have, and all the rest are treated as metals. Same as a star, really. So once we get more granular with that as to the actual percentages of each type of chemical, then refueling speed will be determined by the chemical quantity in the gas giant specifically, that specific gas giant. So not all gas giants will be equal in terms of how quickly they can refuel the ship. So you could have a gas giant which has an overabundance of helium-3, in which case that's like an amazing fuel station that you can just kind of like rapidly fill your engines from, whereas other gas giants might be really depleted in helium-3, in which case either you sit there for ages waiting for the tanks to fill, or you move on to the next system and see whether they have some more fruit-bearing gas giants. Yeah, we're going to need a massive gas manifold somewhere around the fuel scoop. So where all that hardware comes in, obviously we've got tanks and things all over the ship. So we've got the fuel tanks for the RCS thrusters. We've got the fuel tanks in the big engine pods at the back, because they'll contain the tankage as well for those engines. So that stuff that you're sucking in from the dorsal fin is going to have to be piped literally all over the ship. So those maintenance tunnels are going to be filled with pipework, carrying all this stuff around. And the engines at the back, there is... Well, I've got the actual Magellan open. We've got on the other side of here. So this is the underside of the ring structure. So we're kind of, where are we? Lost. Yeah, so there's the ring, and on either side of that ring, we've got these engineering spaces, which are all grey boxed at the moment. So this is going to be one of the RCS thrusters here, and these are the fuel tanks for the RCS thrusters, and that's the same in all the locations where there are RCS thrusters. So the pipe work for all of this needs to come through into the room that's underneath here, so there'll be stairs going down, and that leads you into what is the network of maintenance tunnels underneath. It's difficult to show at the moment because it's also grey boxed, but so if you imagine a whole load of pipes coming along here, then when you get into the ring, so the actual coils are literally here on the other side of the wall, and up there, can't really see it very well, but that's the inside of the ring. But these stairs go up into the outer area, and again, these are all the tanks and things for the RCS thrusters. But if we continue moving aft towards the back of the ship, then here, these are the engine pylons. So the pipework's going to run all the way down here, and then there'll be access via stairs through here into the engine pylon, which goes all the way down into the engine pod, and that's going to be where you enter from engineering. And in here we're going to have all the fuel tanks and things for the engines. So all that pipework has got a long way to go, and all that needs obviously modeling and laying out. So you should be able to follow those pipes all the way through the maintenance tunnels. So they go all the way around here, all the way down here, all the way around, and then they'll obviously go through here down into here, where it's all coming in. And as with all the other pipes and cables and everything else, you'll be able to follow them literally from source to destination, one cable or pipe at a time. So yeah, good luck finding a broken pipe, because it will be there somewhere. Yeah, it's a difficult one because the FTL drive doesn't use fuel directly because it's electrical. Like all the engines and everything on the ship are all electrical. So it's not how much fuel do you need to get to your destination. It's how long is the reactor going to keep running at the current throttle setting or the reactor setting. So that's something that we can model. So obviously if the reactor is running at 100%, then it's taking big gulps of fuel from your fuel reserves, and we can model how long it's going to take for those fuel reserves to run out with the reactor set the way it is. If you turn the reactor down a bit, then you won't be using as much fuel, but also you won't be going as quickly. But it's not going to be a linear scale. So it's going to be kind of mildly exponential in that the faster you go, or rather the more power you're drawing from the reactor, it's using more fuel. So it's less efficient the more you turn it up. So if you're running low on fuel, you'll get further by going slower. Essentially, that's what I'm trying to say, is the slower you go, as in the lower you have the reactor turned down, the longer your fuel will last, because it's more efficient running at lower power settings. So if you want to turn it up to 100%, 110% to get away from something quickly, then you're going to burn through like the most fuel doing it like that. So it's all about how much fuel the reactor is using, not how much fuel the FTL ring is using, because it's just using electricity. Yeah, well, eventually we'll have a 3D display on the bridge. So all the pipes, cables, and everything else, all the infrastructure, will be renderable as a 3D skeleton on the bridge holo display, and you'll have like red, yellow, green indicators for all of those pipes and things. So if one of them's broken, it'll be flashing red, on the 3D model. So you'll be able to see that that's broken, and you'll see where it's broken. Yeah, the reactor throttle will be on here. So we want to balance this very carefully. Obviously, we have an entire engineering section with all the engineering hardware. What we don't want to do is remove the gameplay from engineering and put it all on the bridge. We want some stuff on the bridge. So I guess regular day-to-day activities things that you're doing all the time need to be doable from the bridge. So things like turning the reactor up and down for FTL needs to be done from the bridge. So we'll probably have an FTL preset, because if you're not actively using the FTL, then you're generating more power than you need, and that excess power has to go somewhere, so we just vent it out the ship as plasma. So what you don't want to be doing is sitting stationary with the reactor dialed up to 100, basically just pooping out plasma from the bottom of the ship because it's got nowhere else to go, because you're just wasting fuel at that point. So when you need the FTL, you'll turn the reactor up. When you're done using the FTL, you'll turn the reactor back down again. So that's something that you're doing all the time. So we want that to happen on the bridge via the engineering UI, rather than having to constantly do stuff down in engineering for that specific thing. Whereas there are going to be other things that we only want to be doing in engineering. So we need to define where that division of responsibility lies, so that we have a clear separation of things you can do on the bridge and things that you need to go down to engineering to do. Obviously, if something's broken, you have to go and physically find the thing that's broken. But yeah, it's going to be a bit of a balancing act, because we want to make sure there's enough bridge gameplay for engineering without taking that gameplay away from the actual engineering section. Yes, Max. That's part of the stuff that will be modeled once we have like the actual engines themselves modeled. Because right now, like the FTL coils themselves, the individual coils are not modeled. It's just a case of, is the FTL engine on or not? It's a very simple binary thing. Once the hardware is modeled, then we'll have literally per coil numbers. And then the overall efficiency of the FTL ring is literally the sum of its parts. So each one of these is actually made up of a lot of individual rings. You can probably tell from here. So we've got one coil like this, and this one coil is duplicated a lot. Can't remember how many of them there are, but I remember it being a lot. It's not one. Many. Many. There are many of them, but each one of these is an individually placed coil. This is not one solid mesh. They're all separate. So the health value of each of these will all contribute towards the overall efficiency of the FTL. So like with everything else in the game, it's very, very organic, and everything affects everything else. So it's never a simple answer, because it's always a sum of its parts. So if one of these FTL coils blows, that's not going to stop you going to FTL, but your top speed will be affected, because all of a sudden you can't create a field that's as strong as it otherwise would have been. But that also then affects the fuel draw, it affects the power draw from the reactor, which in turn then affects the fuel draw. And of course, on top of that, you've got the thrust being provided by the engines, which is also factored into it. So there's like a dozen different things all working in concert to produce the final result. I may have made it more complicated than it needs to be. But still, that's what we get when we simulate stuff, I suppose. Right, that's enough yap. Let's do something. So here's the UI, and where is it? There it is. So we need to add to this, essentially, what we've got downstairs here in the coolant room. If I can find it. It's around here somewhere. So we're going to grab these displays here. We won't worry about things like the cable name, the pipe names, or anything like that. We just want the actual tank graphic, the name of the tank, and I guess we'll take things like pressure, fill level, and temperature, and we can kind of model that onto it. So if we grab that UI as well, then we can do some copy pasting. And then the other thing we need to do is query the tanks in the world so that we can get their actual values. So we should have a lot of that exposed already as variables. So we can grab things like current fill. Yeah, that one. Yeah, so we'll make sure that we can expose these. And right now, I don't believe it's replicating a lot of this. So we need to make sure that we're set up for replication so that it all says the right thing in multiplayer. I don't know if it's even a replicate thing. Yes, okay, so we are replicating the actor. But we're not necessarily replicating the variables. So yeah, so some of these are going to have to be flagged for replication, and then we can feed that through to the individual UIs. And let's just do the graphical side first. To be honest, Lutz, a lot of it's already happening. So when it comes to the reactor calculations, all the fluid pipes and all that sort of stuff, that's already done and modeled in the game. So the additional stuff is basically just math. It's not going to be CPU intensive. It's just complicated to work out. Because all we're doing is we're taking output values from the various different contributing systems, and then we're combining those values via a formula to produce our final result. So it's literally just math. So yeah, it shouldn't be computationally intensive, just complicated on my brain to work it out. Maybe PSV, yeah, to some extent. Again, we're walking that line between simulating the ship and it being a game. You know, we can't kind of lose sight of the fact that it also needs to be a game. So we have to kind of be mindful of the fact that if we do everything on the bridge, then those activities are being taken away from the other areas of the ship. So we need to have a reason to visit those other areas and not just say, right, this is a bridge sim and everything happens on the bridge. So where it makes sense to have it on the bridge, then we'll have it on the bridge. Otherwise, we'll hand that off to the other sections. Like the probe gameplay, for example. So the bridge will be responsible for targeting somewhere they want a probe to go to, and they will be able to request that probe from the bridge. But the bridge has no responsibility over physically launching the probe. That request goes down to the probe room on C-Deck, and the guys in the probe room are the ones that then configure the probe to be appropriate for the target, launch the probe, and then handle that probe when it returns. So from the point of request, the bridge no longer has a hand in that. It's all handed off to the actual location that deals with it. So we'll have that for most things, I would have thought, where we do the initial stuff on the bridge, so the initial orders, the initial creation of whatever we want to do, and then it gets handed off to the individual department that deals with it. Celtic, yeah. So there will definitely be a fully 3D ship on the bridge that you can pull the layers off of to see exactly what's broken, where it's broken, and yeah, we will have, at least in the internal security as well, we'll have little indicators to show where people are on the ship. So we'll have 3D decks. And we already have 3D models of the decks, so it's not a stretch just to make them smaller and put them on holo display. And then we'll have like little glowing capsules to indicate where players are. So it's not a stretch to also include that to the engineering side of things, where we can see the individual engineers and we can guide them to what might be broken via that holo display. But the same holo display will also be in the engineering control room. So again, the engineering team can manage themselves from engineering. That doesn't need to be done from the bridge. And again, the engineering control room is the backup bridge as well, so it will have all the same stuff that the bridge has. Yeah, sorry Danger Mouse, I'll get on with some work, shall I? This is how it goes sometimes. We end up just chatting rather than doing something useful. Right, so we got our tank graphic, we've got our border, we've got our progress bar which fills it up. So we need to take a copy of that and we need to move that onto here, like so. Why did that vanish? I see, because we're on a widget switcher. So we'll pop that on that canvas panel there. Right. So we're going to have to do this for each of the tanks. I will only do it to the 3 tanks that are actually in use right now. Obviously we've got a second deuterium tank which is currently not plumbed in, so we'll stick to the 3 that actually drain, otherwise it will look weird. Okay, so we've got helium for our coolant, and then we've got helium 3 for 1/2 of our fuel mix, and then we've got deuterium for the other half of our fuel mix. Which one are you? So helium. Oh, no, don't do that. Okay, and I was going to say I'll make them bigger, but I think we'll leave them scaled to this size because we're also going to have the reactor on here as well. Actually, we can probably just steal a reactor graphic, or did I not make one? Oh no, I didn't. No, I did have a reactor graphic, but it was terrible, so I stopped using it. Yeah, I got the pump, the chiller. I must have deleted the reactor one because it truly was awful. we won't worry about that one then. Yeah, so eventually the vision for this is we want a graphic representing the reactor in the middle. So just basically a 2D picture of the reactor. And then all of these different elements like the fuel supplies and things will go around it with their various feeds indicated. So the final vision for the power system display is we need all of the battery arrays represented on here. We need the coolant loop, the fuel loop, all of that kind of needs to be squeezed into one giant overview page if we can squeeze it in. So we don't need individual battery cells as such on here, but we could do with each battery array. So what's that? There's 6 per room, 12, 24, 48. There's 72 battery arrays, or 48? No, 48 battery arrays. Yeah, so we need to fit 48 battery arrays on here. Plus the reactor graphic, plus the tank graphics, plus little graphics for the pumps and the chillers. I think we can fit it all on. It's a big screen. But yeah, it's going to be a bit of a squeeze. Yeah, and then we'll grab these. Yeah, since I made this particular UI, or rather, since I cobbled together this particular UI, I've made nicer graphics that don't have all these individual elements on them. So I think what we'll do is we'll use the newer version of them. I think I called them that. Yeah, so it's the same thing that we have on this UI, only it's an actual pre-configured widget, so that I can change things like the size, the title, and all the rest of it, and it should scale automatically. So if I was to do that, it keeps everything all consistent. So you want to go there, and so as if I duplicate these like this for each one, and I can fit all those just sideways. There's enough room for all three of them. And then we can just fill out the numbers on those as needed. So let's align this one to the middle. And let's say, actually need a title above it, so let's go 250 maybe. We put these in the same place anchor wise. Move that on the opposite side. Right, that just lines them up evenly. And then we've got some info boxes for each one. refueling stream. Yeah, the reason we're using helium is because it is fairly abundant in gas giants. Well, it's fairly abundant everywhere, and you can make liquid helium practically absolute zero. So it is like the superior coolant. Although I suppose maybe hydrogen is a backup, but I think helium is so abundant in the universe that it shouldn't ever be a problem. Yeah, we can make this tabbed at some point, but it is a big screen, so obviously we need to fill that screen up. We kind of want to get to the point where we have a lot of screens and readouts around the bridge, but only where they are relevant and mean something. So again, our mantra for the game is that no button should be just there as a fake button that just there to look good. In the same way, no UI should ever be there just for the sake of it. It should always serve some kind of actual practical purpose. Because I'm not a fan of fakery in games. I think I'm going to wrap these in a grid box so that I can center them, center them here on each one, just to make the layout a little bit nicer. Chris, the one we're making is kind of helium type reactor. We're using a design from Tri-Alpha Energy, but it's the same kind of thing. It's a direct harvest fusion reactor. So it's not heating up water and turning a steam turbine. It's using the pressure against the magnetic field from the fusion reaction to generate electrical current. So it's pushing against that EM field, basically. So it is a direct harvest reactor. No steam involved. Right, so we want those ones and that one, and we want to wrap them with a grid panel. And then we want that one to be column 1, row span 3, and we got 0, 0, 1, 0, and 2, 0. And then we'll give a little bit of left padding on this one. And we'll stick a wire on that too. So if we do we make that column 1, and then we stick that on column 2, and that gives us our little line in the middle. So we want that to be horizontal. We'll remove the padding from this one. And then we shall scale that down a bit. There we go, just to link them together visually. Okay, so that one's going to be column 1, row 1. And then that one's going to be column 1, row 2, just to line those up like that, and To be honest, I may as well just duplicate this whole thing rather than doing it again over there. Okay. Right, so what do we have? We've got... I'll go fill level at the top, and then we'll go temperature and pressure. So fill level. Oops. Temperature. And pressure. And then of course each one of these is going to need the actual text. Oh, Zephyrd, thank you. I need it. Richard Silverwings, welcome. And thank you. The demo is a year old now, so we've made quite a bit of progress in the past year. And at some point this millennium, it's going to be updated. I'm not a huge coffee drinker, but if I ever do choose to have a coffee, I guess I always get some kind of latte with some kind of syrup in it. So yeah, like a caramel latte, something like that usually. I drink yuppie coffee. And yes, I drink a lot of Earl Grey. Although, as I often feel the need to point out, not for the reasons you might think. I drink Earl Grey because it's what my mum's always drank. So yeah, I got it from that, not Star Trek. The fact that it's Picard's drink of choice is just a happy coincidence. So make sure we got a note of that one. We don't need that as a variable. Shouldn't need that or them as variables either. So yeah, it's literally just the tank graphics, the only thing we're going to need to update. And then of course the text. Actually, shall I grab the same text size and font we're using on this one? Okay, weird. Why is that underneath it? Oh, because it's on a grid panel. Of course, of course. Well, that's awkward. So I need... So, imported widgets can't have children. So obviously both of these are in the same slot. Do we have a render layer? Oh yeah, we do. Ah, there we go. That solves that problem. Doesn't quite explain why it's not properly aligned though. Okay, so the next one's going to be row 1, and the next one's going to be row 2. Richard Silverwings, thank you. Very much appreciated. I don't actually recognise that currency. What's a RON? Oh, Romanian. Cool. Thank you. I actually have family in Romania, so that's really cool. They come from Tigamuresh, if you know where that is. Oh, a wild Claire has appeared. Ah, she's delivering me Earl Grey.
So Earl Grey.
Why, thank you.
You're welcome. Oh, incoming.
I hear a cat.
Yes. Hello, peoples. Where am I? There I am.
You're over there somewhere. Look, we're both sporting the same T-shirt today as well. Both got our Starship T-shirts on.
It's because we went out.
Yeah, it's because we left the house. That rarely happens.
Advertising.
Yeah. If leaving the house, put the T-shirt on.
Come on. Bye.
See you later. But yes, I do love a cup of Earl Grey. Yeah, she doesn't venture out to the office very often. I mean, she does have a desk and a chair next to me, but she tends to just sit in the nice warm house instead. Yeah, she doesn't hang about. She comes in and she's gone like the wind. I suppose I should define what we're dealing with here. So that one's helium, and helium. Okay, so they're all variables, and so is that. So these are the only ones that need a specific name because we're going to be referencing them in code. So if we delete this lot, because I'm going to replace it with the ones we just made. I suppose, I wonder if I can squeeze a title into this as well. That would be useful if I could. Yeah, let's grab that one. So we want it to be column span 3, so that it's in the middle. Can we do minuses on here? No. Okay, so if that's going to be row 0, then we're going to have to move everything else down. So you're going to be row 1. So row 1, actually let's do the bottom ones. So you go to row 3, you go to row 2, row 3, row 2, row 1, and the same with these. Oh, actually I forgot I could just press the button, can't I? I always forget that. And then the text needs to not be quite so wide. Guess that's not going to work. It's pushing out this central one. Or if I do it column 1. Okay. I don't think I can do this unless we stick it there. We do that. Maybe wrap it with a size box. Yeah, that works. Okay, now it's going to push out the middle. Alright, now we can't have that in this box because it'll mess it up. But that's fine because it can just go above it instead. Get rid of that. Lines everything up. So that's our helium grid panel. So all we need to do now is just duplicate that. No, I don't want you on it, I want you under it. Okay, so let's title helium. Oops. And that one is title helium 3. And that needs to go there. Then we'll just rename these. So helium 3, helium 3, and all the way down. Again, we only need to rename the ones which are being used as variables. The rest of them are fine as they are. Okay, so center justified 220. We can call that one helium 3. And then we do the same job for the deuterium. center justified, 800 across, 150 down. And then just rename these. Otherwise, it will get confusing. Right, so that gives us our graphics on the bridge. It will look messed up until it's rendered in game. Should look like that in game, which I shall try out on the test map shortly. Actually, that's a point. So that the test map obviously doesn't have any of the tankage because it's using fake power. So we're going to have to test this on the actual Magellan to make sure that all of this actually works. And then what we'll do, I think, to keep this quick and simple, I guess we'll just have a function ticking away on here, which is grabbing the details from those actors in the world. So if we actually, let's see whether we've tagged them already. Because we'll just get actors with tag, and we'll tag those tanks accordingly. Yes, we do. Yeah, so I'm going to get them with their tag, and that will make life a bit easier for just for our version 1 of this. So get all actors of class with tag. So the class is fluid tank, and the tag is that one. Oh, actually, yeah. And before we go ahead and do any of this, what's this one doing? Yeah, that can stay as is. So we want to listen for gameplay message. And we want to specifically look for our startup sequence levels loaded, because we don't want to look for it until we know it's going to be there. Just give it a dummy struct, otherwise it won't do anything. So now that we know the levels are loaded, we know it's safe to get a copy of that reference, and there's only one of them, so we know there's only going to be we know it's going to be item 0, and then we can now promote that to a variable. So this is our helium tank. So that gives us a hard reference now to that tank. And I suppose rather than doing that 3 times, we'll just branch this. So do that one for the helium, and then we'll do helium 3, and then we'll do deuterium. Now I'm assuming that I would have named them like that, logically, but we can never be sure that I did, so let's just check them. So cryotank HE3, and that one is DA, because that one is going to be DB. Yes, so it's only DA that we're interested in, because the other one's not actually connected up yet. Right, and then we'll promote this one to a variable as well. So that's our helium 3 tank reference. And then this one is going to be our deuterium tank reference. Okay, So we now have access to all three of those. Oh, it's already the right type, so I don't need to cast to it. So that will save us pain in the future. So we now should be able to just get fill level. Get fill. Words, typing, correct. There we go. Get current fill. So we can now just pull off that value whenever we want it. So having done all of that, I think the next thing we'll do, and we'll do it from here. No, actually, no, we won't. What we'll do is we will do it so it starts doing its tick once the player is ready. So character ready. So as part of our startup sequence, obviously it goes through different stages of ship startup. The last thing on the list is character ready. So when the character's been spawned and the spawned character says, right, I'm ready for gameplay, then it fades from black into the game, and then the player has control over the character. So at that point is when we will start ticking these values. This obviously happens a lot sooner, so we can do the setup work first during the loading screen, and then actually start ticking when we're in game. So if we do timer by function name, and we create a function called get tank info, or get tank data, that sounded a little bit more professional, and we can do that once per second. So we don't need to be doing this hugely frequently. Just once per second it will update the tank details, which just means we then need a function of the same name, otherwise it won't work. And then we can grab our three references. Actually, those are the sets. We don't want the sets, we want the gets. So get that, get that, get that, and then we take. We don't want our wires. Why are they down as variables? We don't want them as variables. They're just getting all up in our way. Got it. Right, so we want if we do fill level first, so we got helium 3 and deuterium. In fact, if we do the helium one in its entirety, then we can just copy paste it. So we just want to set text on that. And get fill. We're going to have to format this so that it has the right unit of measurement. And then on here we want to make sure we only round to 2 fractional digits. And we'll make a macro for this, but for now we'll just pipe that in. So let's just say L. Let's assume it's liters, but we'll go back and double check that for sure. Okay, so that's that one, and then we need temperature and pressure. So same thing, we just set text. In fact, let's just duplicate that because it's quicker. So we know that this one's in Kelvin, so we can just stick a K on it. And then, as before, we grab our reference, we get current tank temperature, and again we're going to do that to Actually, on this one, we don't want any decimals. So we're going to round this to 0 decimal places because they're doing Kelvin. Okay, and then the pressure, if we grab that again, pop that there. And this one's going to be pressure. So get current tank pressure, pop that in there, and tell it which box we're updating. Actually, yeah, and in addition to the text for the fill, in fact, let's probably do this one first. We need to set the fill graphic, which is essentially a progress bar. So I've upended a progress bar and given it kind of rounded corners, and that serves as our fill graphic. So we just need to set % on that, and then to get the percentage we need to get our current fill divided by our capacity. That should give us our percentage, unless I have derped on the math. That should be what we need. Okay, so once per second we basically grab these values and update the fields, and then we want to do this for all 3 of our tanks. So if we make a sequence, that was our helium. And then we'll just duplicate all of this twice, like that. And then we just need to replace these values with their respective tank. So we got helium 3, helium 3. Just make sure we don't miss any. And then our progress bar, helium 3, fluid fill, helium 3, temp, helium 3, and pressure, helium 3. And then the same for these ones. So we want, oops, new. That one, that's what I wanted. So deuterium, and deuterium, and then progress bar, deuterium, fill deuterium, temperature deuterium, and pressure deuterium, and then get rid of them. Okay, so once per second, it should now be updating all the values in all the boxes. And just to keep it clean, we'll turn off those so they don't appear in our list. So that handles our display, and the display manages itself, so we don't need to drive that from a blueprint or anything. So we grab references to the tanks and then we just extract the values as needed. But the other thing we need to do is we we need to start and stop the refueling process. So the best way of doing this, I think what we'll do, so I'm just thinking about how we're going to start this up. So if we're cold and dark, obviously it sets all the tanks to empty, because we're refilling them from our space dock, essentially, from our external services. If it's not cold and dark, then it starts the game with all the tanks full. So I think what I'll do is I'll set it so we start the game with all the tanks on 10%. So if we grab a reference to the tank and just check our startup. So yeah, so okay, we're using our capacity as the current fill. So I think what we'll do is we'll take our capacity and multiply that by 0.1, so that we're filling it 10%, essentially, and everything else can stay as is. So it just gives us a bit of fuel to work with. I guess for a brand new game, once we're done testing, we'll set that back to 100%. But for testing purposes, we want to see that it's actually reading those values correctly. And these valves need to start in an off position. So I think I set these up to do that. So yeah, so open on flight ready, no. Open on flight ready, no. And the same with these ones. So that so the tanks will actually genuinely drain and not be automatically filled as the ship's flying. So basically when the game starts, we should be only on 10% fuel and going down, because we're not actually refilling it at all. Okay. It takes an absolute age to launch the game in the editor, so I'm actually tempted just to package this and just run it from disk packaged. So let's just do that. Because ironically, I think it's actually quicker to package it than it is to try and run it in the editor. Let's see if I can catch up with chat a little bit. Yeah, your Delta teleport bug. No, don't know. I've tried to replicate that bug over and over and over and over, and it doesn't seem to matter which way I do it. The ship never teleports for me. So how you manage that is a mystery. It could be frame rate related. It could be anything really. But yeah, I'm baffled. I'm going to have to keep looking at it. I don't think our captain will be adverse to taking the odd sip of whiskey, even while on duty. Helps calm the nerves. What was that? Oh, it's that random I'm going to fail to package for no reason at all. Now, all we need to do is just save it, close it, reopen it, and it should package. Let's try that again. Even reloading it is probably still quicker than running it in the engine. So we are focusing on the Milky Way galaxy and the dwarf galaxies that surround us. So we've got plans for the Magellanic Clouds. I think they are a great place to be squirreling away some endgame content because they're physically isolated from the main galaxy. And they are quite far away, so it's both a time and effort investment to get to the Magellanic Clouds, and if we make the Magellanic Clouds kind of end game content in terms of your ship's capabilities and what you find there, then it's a nice way of including them in the game and making them meaningful. But beyond the Magellanic Clouds, no, there won't be anything worth flying to. We'll have the entire galactic halo generating stars, so that halo extends out to, at least the way we've got it modeled, about a radius and a half from the main galactic disk. So you're looking at about 100,000 light years from Sag A before you'll stop finding stars. And then you'll be truly in intergalactic space. And it actually does say intergalactic space on the UI, when you reach that far. If you were to try to fly to Andromeda at 300 light years per hour, which is how fast our ship moves, it would still take you over a year, real-time, constant flight to get there. It is a very, very long way away. So there's no way you could just fly there. I mean, you'd have to put a lot of time aside, run the game 24/7, hope you don't run out of fuel or resources. You'd have to line the corridors with fuel tanks, and I don't think you'd make it even still. So we're not planning on including anything beyond the galactic halo. I think that's enough space as it stands. I mean, look at Elite's galaxy. It's been explored less than 1%, and it's been going for 12 years now, with thousands of players per day, and for that many people over that amount of time, exploring it so little, I don't think we need to go any further than that. The galaxy is big enough as it stands. the reason that we picked 300 light years an hour specifically, it's actually like 289 if we're being exact, is because the average distance between stars in our region of the galaxy is about 4 light years. So I wanted it to be about a minute between stars. So if we consider a star system as a place for content to exist, so gameplay happens inside a star system, the next star system, the next source of gameplay, is about a minute away, if you're going from star to star to star. So we scaled the speed of the ship based on the next bit of content being a minute away. It's actually like 51 seconds, I think, at the speed the ship's going right now. Faster than that, and you're getting around too quickly. I mean, it takes about 2.5, almost 3 days to get to Sat J, and 2 full weeks to go from one side of the galaxy to the other. But I'm okay with that because the galaxy is huge, and the next star only being 1 minute away, I think is quick enough to get from content to content. That will change because once we have stars affecting the effectiveness of the FTL, that will cause the ship to be slower around stars, but it will all balance out. Yeah, all the different ships will have different speeds, and the total speed of the ship is that the thrust output of the sublight engines multiplied by the FTL field strength in the direction of motion. So if the ship is slightly off from the direction of travel, so you're not truly facing prograde, then the FTL field will be less effective. But yeah, so all of that combined produces the speed of the ship. But that's only if you're using warp technology. If you're using hyperspace technology, then the ship will get around the galaxy a bit quicker because you're now moving through hyperspace. And then whatever other FTL tech we add. Let's just fix these errors. These would have needed fixing anyway, so that's not a problem. It's because I was removing references to stuff. Yeah. So a lot of this stuff is like legacy code, which I've had to like clean up and get rid of, but of course there are still some legacy references lingering, which is causing some of these errors. So that was that one, and also that one. What's broken on this one? Oh, yeah, same thing. So that. Okay, let's fix that one. Is there anything else? So just orbit controls, orbit widgets, same one there. Yeah, okay, clear the log and try again. Yeah, the Caravella is fixed now for the next build that I put out. So you'll be able to access the Caravella from the menu. I haven't touched it obviously in months, so I'm not quite sure what state it's in. The sublight controls didn't seem to be working, so I will pick that up again once the demo update goes out, and we'll find out exactly what's wrong with it. Yeah, every single ship will have a tech manual with it that will go into an extreme amount of nerdy detail. I will not hold back on how nerdy they will be. Player-based modding is going to be difficult because like the individual ships themselves, without wanting to disparage modding capability, having been a modder myself once, I think it's too much work to mod an entire vessel, simply because each vessel is multiple in-game levels and literally tens of thousands of individual pieces. There is just so much involved in creating a single vessel that I don't think it's practical to be able to mod one in. I wouldn't even know where to start. It's not just an empty shell flying around, it's like the full ship. That said, it's probably going to be possible to mod bits of the ship, so like replacing the wall panels with a different style of wall panel. Again, there are hundreds of different individual wall panels per ship, but that is potentially moddable. So you could do like visual overhauls for a ship without touching where all the wires and pipes go. Yeah, I guess things like custom galaxies, custom star systems, we're baking that into the game anyway, so that won't need to be modded. There'll be a star system creator on the main menu, and you'll be able to make as many custom star systems as you want, name them what you want, put them where you want, populate them with who you want, and that will be available in your local game or any game that you host in multiplayer. So we don't need modding in that regard. We'll just have to see, I guess. If it's possible and practical, I have no problem with it. I'm not against modding. As I said, I used to be a modder myself. My Skyrim install has a lot of mods, so I will embrace the modding community where practical. Thank you, Richard. Very, very much appreciated. Joe Coffin, yes. Our second highest player base is actually German. So we get a lot of German players playing the game. So German localization will probably be the first one we do. Potentially, Lud. Again, it's a difficult one to answer because the ships in the game and the hardware is so handcrafted that I think modding it would be challenging. But yeah, I'll never say never. And when it comes to different FTL technologies, obviously warp we're putting in as like the version 1 tech. So as a species achieves FTL capability, warp engines are the first thing they do. So Alcubierre drives and their equivalent. That's kind of like the entry level tech. From there, we move into hyperspace, and there'll be two flavors of that. One of them will be hyperspace tunneling, which is a point-to-point hyperspace journey, I guess like you see in Star Wars. So you get the pretty tunnel as you're flying through hyperspace. Hyperspace actual, when you're actually entering hyperspace, like what you see in Babylon 5, that will kind of be like the next tech up from there. From there, we'll do artificial wormholes. So basically jump gates, or stargates. And then above that, we'll have interdimensional travel, where you'll be able to literally phase from one location in the galaxy and then phase back in somewhere else. So you're phasing out of existence essentially and just rephasing somewhere. The highest tech aliens in the game will be using phasing technology to get where they're going. So different alien species, depending on their tech level, will get around the galaxy using different technologies. And all of those different technologies will be installable on your ship. So if you get friendly with an alien race, they agree to share the technology with you, then you can literally retrofit your ship to use hyperspace rather than warp. And you'll be able to get around that much quicker. So the warp engines that you start with are literally like the slowest way of getting around the galaxy, and the extra technologies that you learn will get you from A to B that much quicker, as you progress through the hardware and the tech levels. But obviously the engineering and the science team on your ship will need to be skilled up to that level in order for you to be able to actually use that technology. So there's going to be a lot of work involved in researching the hardware and in 3D printing the pieces, getting the resources, and all that stuff. Oh, Max, thank you. Very much appreciated. Yes, PSV, there won't be any tech trees in the game. All of the upgrades are achieved through exploration, discovery, and then science. So you could find an alien derelict or an alien station that's been abandoned. You can then board those vessels or that station. You could find a piece of alien tech, which might be a higher tech level than you are right now. You then bring that tech aboard your ship. You do the science on that tech, and that might unlock some new thing for your ship, an improved way of doing something. It could be something as mundane as a cable which doesn't heat up as much or is more resilient to damage. Or it could be vastly more efficient shield generators. So all of the upgrades are sourced through discovery and science. It's not just oh, you've got so many points, now you can spend them on a tech tree. Nothing like that. Nah, it's not as complicated as it sounds. In many ways, it's easier than a tech tree because it's one less UI for me to make. Exactly, Zephyr, yeah. So if you happen to stumble across the ruins of like a tech level 50 civilization, which is the cap, and you find some alien shield generator, which is tech level 50, then your engineering crew and your science team and all of that will all need to be level 50 in order to be able to fit that on your ship. So that would be like an end game piece of hardware that will just sit on a shelf somewhere until you are skilled up enough to understand it. Because the idea is this technology is so advanced you wouldn't even know where to start with integrating into your ship. So you'd need to really skill all that up so that you could do it. I seem to have broken something. I bet that is the result of me messing with the tanks. Oh, and actually, let's leave that plugged in a minute. It's probably the chiller's not receiving anything from the info. Chiller. There we go. Yeah. So as we step through our process, so we need to make sure that we're powered, we're active. Okay, so we're initializing the chillers. Make sure. Okay, so we're not sending anything. Just need to go back through the chain of events to make sure that we are actually outputting fluid. Okay, so basically each of the inputs correspond to the different pipes. So you've got the refill pipe, you've got the return pipe from the reactor, and then you've got the overflow pipe from the tank. All three of those pipes go into the chiller. Yeah, and we're taking the maximum pressure, the maximum temperature from those. We're adding all the volumes together, and that's our that's how much fluid we're passing on in the system. So that should be working, but let's turn those valves back on the back wall and see whether or not that is what's causing the issue. Yeah, the one deuterium tank that's not draining is fine, because that's just a bit of a backup tank. It's more of an overflow. It's not actually needed to power the reactor. I included two because we're using basically a 50-50 mix for the deuterium and helium-3, and I need to research that more, because I've seen different explanations as to what the optimal mix would be. But we're also using deuterium for the beam injectors. So these yellow capped things are neutral beam injectors, which induce spin in the helium. That's what in the plasma stream. So you get these FRCs, field reversed configuration plasma, which is fired and compressed through these accelerator coils, and they combine in the middle, and that fusion reaction is kept stable by the neutral beam injectors inducing kinetic spin to the plasma stream, so that kind of holds it in place whilst the fusion does its thing. And they use fuel as well to do that, so that's why there's more deuterium than there is helium-3. But I think it's such a small amount difference that it doesn't really warrant an entire other tank. So either we'll lose the other tank, which would look weird because we'd have an asymmetric room, or we'll store something else in it, like, I don't know, orange juice. Right, so let's turn on those. This should package a lot quicker now as well. Once you've packaged it once, it speeds up the next time. Yeah, I vote whiskey tank. That's the ship's Jack Daniel's supply. It's true, there is still a lot of ship to build. Yeah, there's a brig down on E-Deck. It's next to the shuttle bay. You can brig yourself via pressing, I think, F9. If you press F9, you can brig yourself, you'll appear there. And if you then unbrig yourself, you'll be outside the brig. But yeah, it's down on E-Deck. Is it F6? Yeah, thank you, AJ. I can never remember which one it is. Yeah, AI code's got better. We went through a real inflection point in January. I think the latest headline models are doing a very good job. I mean, I'm using it to help us build the website. I don't think I trust it to build any of the core game systems, but yeah, website work, it saves a lot of time. Yeah, oxygen tank's not a bad shout, especially as we'd be storing it as liquid oxygen as well. Yeah, liquid oxygen, that's not a bad shout. Yeah, at some point I'll look into a local model for NPC dialogue, but we don't have NPCs that are interactable on that level yet, so we will wait until we do. Yeah, we'd have to do asteroid mining, I suppose, for oxygen. Strip it out of the water. Yeah, absolutely, Quick as me. It'd always be completely optional. As I've said many times, my line in the sand and my policy for having an LLM within the game for NPC dialogue only would be a local model running in the game engine that doesn't require a separate server executable or require any external connectivity to work. So if it's not a process running in the game client and only in the game client, then we won't do it. And even if we do it in the game client, it will always be purely optional. So you can turn it off. But it is by far the most effective way of achieving really deep NPC dialogue. And of course we'd train it on our own data as well, so you wouldn't be able to ask it about the latest football scores. It would be purely in-game knowledge only. Yeah, talk about adding fuel to the fire. Yeah. Oh, I do use Claude Code for reviewing bugs and things. If something's gone wrong and I can't figure it out, then it's so much quicker to just ask an LLM, say, hey, figure out what's wrong with my code, than it would be to spend hours poring over it myself. That's going to need updating. I think that's probably in milliliters, so that needs converting to liters. But the code is working. It's updating every second. So these tanks are filling currently because the valves are on, and you can see it's getting the live readout from the valves. If I teleport down to here, and this all matches, which is good. So we'll turn off these valves. So basically that's our refueling loop closed. So these tanks now can only drain. So you'll see that the fill level is now going down because the reactor is running. They take a while to drain, obviously. So one of the things obviously we need to do with this is have them drain quicker when the reactor is going full bore. I think someone worked out it takes about an hour to drain at the moment. But yeah, so that will now be draining. I'm pretty sure I haven't modeled extra power usage yet in that, so I don't think. No, it's still going down at the same speed, mainly because the reactor is still running at 100%. If I was to turn the reactor down, it would use less fuel. So what we need to do in terms of balance and working out like how often we need to refuel the ship is we need to look at like how far can you fly on maximum power before the fuel runs out. And thank you, Festus. Yeah, so 1 hour 28 minutes is probably about 1 hour too long. So we need to refuel, I would say, approximately once per sector. So a sector is 100 light years. So I think if you're stopping off at a gas giant once every 100 light years, that feels like a decent number to refuel at. Ian, yes, I also use it for research as well. So obviously with the game we're making, with like the electrical simulation, so I needed to do a lot of research on electrical engineering. With the galaxy side of things, obviously there's a lot of astrophysics, and I find myself spending hours just learning through AI models. Going off and sending them off on research projects. Like the deep research capabilities are really useful. So if there's a particular thing that I need to know, like what's the stellar density difference between a galactic arm region and the inter-arm region? Like, we know that the galactic arms have a higher stellar density than the inter-arm regions, but to what extent? And if you try and just look that up on Google, then you're not going to find an answer. It's just one of those questions that it's difficult to find the answer to. But if you send an AI model off on a deep research project, then it will come back with a report on what it finds and cited papers from the science community that you can go through. So from a research perspective, I couldn't do it without it, basically, because it's really kind of funneling the information that I need, like, to a really nice, concise report, so that I can then go through that, and then I know what the different stellar densities are, so I can then add that to the modeling and make sure that our galaxy is correct in terms of that sort of thing. And there are many aspects of of the galaxy gen and other aspects of the astrophysics where, not being a PhD level astrophysicist myself or having one immediately to hand, I need these research projects to get the information for me. Because I'd rather be working off of actual science papers than just guessing. Right, so what's next? Let's add a button, shall we? So we need to start and stop the refueling loop. And I think the easiest way to do that is probably remote control of these particular valves. And then we will up the flow rate of those considerably, so that it's only taking a couple of minutes to refill the tanks rather than having to spend hours looking at it. The literage of the tanks is correct for their size, so we can't change the tank capacity because that's modeled in SketchUp, so it does a volume calculation on that, so we know how much fluid they contain. So we're going to have to up the amount of fuel the reactor uses instead per fusion tick, which means we need to push more fuel through the pipes to the reactor. Yeah, so let's add the start and the stop for those, which will have to be yeah, if we do it as a global event, then they can just react to that globally rather than having to grab these actors specifically in the world. I think in the final version we'll definitely reference the valves themselves directly, because we've got like data cables to add to this yet. But yeah, for now we'll just do a remote broadcast and trigger them via a button that way. Yeah, absolutely, Illusion, which is why I use them to fetch the relevant science papers. So that's the nice thing. When they actually cite the sources, you can go through the paper itself. So although, yes, the research project is giving you an overview, you still have those actual peer-reviewed papers that you can go through for confirmation. But generally, I found they've been correct because they're citing those papers rather than trying to come up with the answer themselves. So it kind of limits the hallucination. Make sure we use the right button so that it inherits all of our customization. Offset these from the top as well, centered. So we'll do, what's the best way of calling this? What if we do initiate gas collection? Oops. Or open gas collector or open gas scoop. Words to that effect. Okay, so if we do minus 150, that one will be plus 150. It just keeps them centralized to the display. And that one would be close gas collector. Yeah, we do need to add that to the sensors. I mean, most systems do have multiple gas giants, so I don't think finding a suitable one is ever going to be an issue, because it's very rare that a star system doesn't have a gas giant in it. Yeah, this is one of those like gameplay versus scientific realism things. So like most gas giants are like predominantly hydrogen and helium. I think the ice giants are a bit different because they've got a slightly different chemical makeup, but the percentages are different. But you know, the bulk of gas giants are literally made of helium, of hydrogen, which is basically deuterium. So there's bountiful fuel out there. So from a gameplay perspective, we can't limit the amount of available fuel per gas giant, because that's not scientifically accurate. We want to make sure that our gas giants have scientifically accurate chemical makeups. So obviously the parts per million, I suppose, is what we're going to use to define refueling speed. So some gas giants are going to refuel you quicker than others based on those speeds. Yeah, it's going to be an interesting one to balance. I mean, it might just be the case that that refueling the ship, you know, isn't a big deal. You know, it doesn't have to be a hardship. It's part of the standard operation of the vessel. It doesn't need to be complicated gameplay. It's just something you need to do. But we also want to keep it interesting at the same time. So I think variable refill rates based on parts per million of the gas in question, I think that's a nice way of different gas giants kind of tasting different in terms of refueling the ship. I don't think there are any gas giants that would be unsuitable for refueling. Maybe something like a class 5 gas giant, which is very hot. Perhaps the temperature of the gas giant could preclude refueling. We could do something like that, where we could just say that, you know, we need a certain temperature range to be valid for efficient fuel collection, and if the temperature of a gas giant exceeds that temperature range, then the gas is essentially too hot to scoop. It doesn't, you know, it's not going to work efficiently with our collection hardware. So we can do something like that, because it's science based and kind of lore driven. So yeah, that could work. And we could do it along the lines of the colder the gas giant, the more efficient it is for fuel collection, because obviously we also need to chill this gas down into a liquid. So the colder it is to begin with, the easier it is to collapse into a liquid state. So that can play a factor as well. So I guess there are things we can play around with in terms of how good certain planets are for refueling. So I guess, you know, for helium-3, certainly a really, really cold gas giant that has an abundance of helium-3 is going to fill the helium-3 tank a lot quicker than a warmer one with a lower abundance. So that gives you the different, the different feel of each planet. So you could find a system that has some really nice gas giants for refueling, whereas others are kind of, having to sit around twiddling your thumbs a bit. Yeah, the ice giants do have more helium-3, which is just, good to know. I think on that note, actually, we could make the refilling of these tanks separate. Just to give more buttons to press. So as much as we've got rather than just having one overall fill all the tanks button, it'd be nice to have per tank control. I mean, I guess in the future we need to have it so that the different fuel types are filtered at source, rather than being able to only scoop one at a time. I think having to scoop each tank separately would get old quite quickly. It would be quite boring. But having to open and close the valves on each one separately, I think that's just a quick series of button presses. It's not going to slow the game down too much. So on that note, why don't we instead call it open refill valve and then close refill valve. Yeah, and then we need to make sure that the open refill valve button is only available if you are within range of a gas giant. If you fly away from the gas giant, I guess we need to have it automatically close again. There's going to have to be consequence for leaving it open. I guess if you don't close the refill valve and the gas collection hardware is no longer running, then I guess we'll have it so that it all seeps back out again. So your tank is then leaking backwards through the refill valve because you haven't closed it. So yeah, that can be the consequence. The tank drains out of the input hardware. It would be nice if at some point we can have the tanks mix. So if you configure some valves wrong, then your helium and your helium-3 start mixing together, or your deuterium. I just realized that I didn't name that one deuterium. Yeah, so that could be interesting. We would have to track the different chemical compositions by percentage if we were doing that, but you could essentially salt your fuel supply and result in it needing to be purged and refilled with pure fluid, because you've messed up somewhere and you've polluted your full fuel tanks with something. That could be an interesting one and have that affect the way things run. But yeah, that's kind of a future problem, I think. Right, so we call that one open helium-3, and that one would be close helium-3. And yeah, see if we can group these together and move them underneath that. be nice if we could actually wire a diagram up to that as well. If we wrap these with a canvas. I try not to use canvas panels now wherever I can avoid it, but in this instance it could be useful. Okay, so we want to put that like there, and then we need a wire. So we stick that in the middle. Like that. And we'll stick this one there. So then that one would have to go 100 units down, or 50, so it's in the middle there. And if we make it horizontal, then we can join the buttons together. So if we center that, put this one down 100, and then something like that. Put these over there so they're behind it, and then that one would be there and there. Okay, that just kind of gives it a little bit of connectedness. And then we can just duplicate that to the others. So that one is helium 3 buttons. Make that one helium buttons. Right, so what are we? So that's 630 down, 165 across. So 630 down, and then just eyeball that about there. Close enough. Okay, so the labels can stay the same. So that's open helium, close helium. Okay, then we have deuterium, so that's open deuterium and close deuterium. So that one would go 635. Oh, no, not the button. Go back button. I've forgotten how far away I did it now. 635. Oh, of course, yeah, because that one's offset, so this will also need to be offset. And we are 630 from the top. Oh, hang on a minute. Why is this one behaving differently? Oh, because I typed in 360. About that. Okay, so the idea would be you get to a gas giant, you go open, 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 all 3 tanks start filling, and then when they're full, you just go close, close, close. So it's 3 buttons to press to get the job done. You're right, Ziza. Yeah, I mean, any system would be designed with backflow protection, but we need consequences. We need consequences to leaving the valve open. So, so what consequences could there be if you leave the valve open? Yeah, leaking maybe. There'd have to be some bad consequence for not closing it off properly. And yeah, the collection hardware would need charging, so we'll probably have like a giant capacitor bank around the collection hardware, because it has to like extend out a field for sucking in gas, so that's obviously going to take power. So we'll probably need to charge a capacitor and unleash that, and keep that capacitor charged whilst it's sucking in gas. So it'll be part of the power system. It doesn't necessarily require the ship to be in motion, but the final vision of this is that you are skimming the upper layers of a gas giant. So, like, conceptually, we want that to be like an epic experience. So we want volumetric gas giants. We want the ship literally ploughing through the upper cloud deck of a gas giant, sucking in clouds as it goes to refuel the ship. So think Destiny from Stargate Universe, except it's a gas giant. So we're obviously, the ship is not capable of atmospheric flight or landing, so we are only literally skimming the upper layer of the atmosphere, like the thinner bit. But it needs to be kind of like a visually rich, impressive experience. So you know, we're going all in on volumetric gas giants for that very reason. So yes, you'll need to maintain speed, just not to fall into the gas giant. But yeah, that's kind of the vision. That's where we're going with it. So the idea is you take the ship down into the upper atmosphere of the gas giant, you look out the window, you go, ooh, and look at all those clouds. And then you open the valves, suck them in, and then close the valves and leave. Repeat once every 100 light years. Yeah, I think if you've hit the core of the gas giant, then something went wrong long before that. Gabriel, yes, I think that's not a bad shout. I think every gas giant does need to have its own personality. So yeah, a particularly rough gas giant might make for a particularly rough refueling experience. So yeah, that's definitely something we could factor in. It takes about half an hour to fly from one side of a sector to another. So you would be refueling about once every half an hour. But that's once every half an hour if you are like at full burn traveling in a straight line. So if you're just like poking around star systems and, you know, going to the next star system over, doing some scans, then going to the next star system and doing some scans, it'll be significantly longer than every half an hour. That's only every half an hour if you're literally going full tilt the entire time. So that's 100 light years in a straight line, reactor turned up to full. Yeah, poke around a star system, it will last for much, much longer. Yeah, anyone that's played Elite Dangerous will be familiar with the creaking and groaning that your ship does when you're being interdicted, and we need that level of audible immersion when you are refueling the ship. So there needs to be an audible roar outside because you're ploughing through essentially an atmosphere, and there needs to be lots of creaking and groaning, and the ship needs to not be very happy when you're refueling. Yeah, I guess in terms of the lifetime of the vessel, refueling runs are going to be the sketchiest moment because you're putting the ship in an environment that it's not happy with. It's not designed for atmospheric flight. It's doing so out of necessity for refueling purposes. It's not something you want to be doing regularly. Oh, Danger Mouse, is it your birthday? Happy birthday. Yeah, the ship will have a solar array, so you'll be able to recharge the ship's batteries using solar panels, and that's kind of like the emergency power. So we're going to have it so that the FTL capacitors can run the FTL for a small period of time, and then when those capacitors are dry, that's it. You can't use FTL now because you've got no juice left. However, if you then recharge all the batteries via a star, via the solar panels, then you can once again initiate FTL for a small period of time. So you could probably hop from star system to star system by getting out the solar panels each time to recharge the batteries until you are in range of a gas giant for refueling. So you wouldn't necessarily be completely stranded in space. There will be a backup solution. It's going to be a painful backup solution because you're just going to have to recharge those solar cells, and given that the average distance between stars is 4 light years, we wouldn't want capacitor only FTL to last more than say 5 light years. So it needs to be enough to get you to the next star system, but no further. And then you can obviously then refuel at that star system and hop your way to where you're going. But yeah, it's last resort only. True that, Jack. Yes, yeah. We don't necessarily need to plow all the way into the atmosphere, and we'll definitely do like a risk reward balance on that. So, like, the deeper into the atmosphere you go, the more chance you have of significantly damaging your ship. But your fuel tanks will go zhoop, done. Yeah, I think the solar sails are a very, very low mass thing. They wouldn't be able to move something the size of the Magellan. Not effectively, anyway. Yeah, the reactor should be relatively stable output wise. Yeah, our ship doesn't have structural integrity in the same way that you would find in a traditional game, because our ships are the sum of their parts. So you've got all the individual systems and hardware that make up the vessel, and it's those things that we'd be receiving damage, not the superstructure of the ship. So the ship's actual framework and hull doesn't necessarily have a health value associated with it. In fact, it won't, because it's essentially just an inert mass of metal. But all the systems will, and the individual hull plating tiles will as well. Not in a reportable sense, because that would be madness, but visually they will look more damaged as they become more damaged, and you'll have to go out there and fix them based on visual inspection. But no, the ship won't have like an overall health percentage. In fact, none of the ships will. So if you're talking combat within the game, or just taking damage generally, no ship, be it yours or an alien or anything else, will have a hull percentage number that goes to 0 when they explode. That's just not how we're doing it. Instead, there will be a list of subsystems, and those subsystems individually will have a damage meter associated with them. When all of those are effectively 0, then that ship is just a dead husk in space. It won't just magically explode when they reach 0. There's obviously always a chance that you hit something that can explode, in which case they will. But generally speaking, you are destroying subsystems, not a magic hull number. And the same is true for your vessel. When you're taking damage locationally aboard your vessel, and that damage is affecting systems aboard your vessel and infrastructure with cabling and pipes and blah 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 blah. So where you get hit is what determines what happens next, because it could knock out a vital system, it could knock out a corridor's lighting. It's a very, very one-to-one system. So combat should be interesting as a result. Yeah, there will be no simple HP bars. Yeah, exactly, binary. So, your ship will die in pieces. It's not just going to randomly explode. It will just get sicker and sicker, and things just stop working. Right, so I said that we weren't going to reference these directly, but I think in hindsight we will, because we have open and close valve buttons on a per valve basis, so it would make sense therefore to target these valves directly. So what we'll do is on here, where we are capturing references to the tanks, we will also capture references to the valves as well. So if we do that, okay, then we will move that out of the way. Yeah, so we'll grab the tag for each of these devices, and have the button turn them on and off directly. So if you were standing in engineering and someone presses the button on the bridge, you'll see this start to flash and change state, and you'll see that directly, which would be quite cool. So this one is, oh, actually let's just check for tags, because otherwise it won't work. So that's the helium refill valve number 2. There would be a valve on this side too as well. So that would be valve 1 would be over here, valve 2 there, valve 3 over here. We'll work on these ones because those are the ones that are used in the tutorial. Okay, so that's that one. I'm assuming that one is similarly named. And then whatever I called this one. So that's AO2, that one. That's the one that connects to the tank that we're interested in. Okay, and then we just promote these to the valve. So that's the helium, helium valve. That one is the helium-3 valve. And that one is going to be the deuterium valve. Okay, so that's our that's all our references set up, and then over on here we just need to reference those valves when we press the buttons. So we got our helium valve, helium-3 valve, and deuterium valve. Okay, and we just need to make sure that we actually have a function we can call on this. Generally speaking, we handle the button presses via the UI. Yeah, so that's going through there. So I think the easiest way to handle this is to use these button IDs and send it via this interface. So if we do fluid UI input, that one, I think. I know it's the widget one. I need to rename those. So basically we've got the client side and the server side. That's not immediately obvious from my naming. So we want the message version of that. So we want valve open. I think that's what I called it. I will double check just to be 100% sure, because that's how problems happen when I don't check things. Yep, and the other one is valve closed. Closed or closed? No. Okay. Then we just need to duplicate this for the other valves. So helium-3 open and close. Oops. Deuterium open and close. And then just hook up buttons. Make sure these actually say open and close on them, because I've done that before. Okay, so by using this interface, what we're actually doing is we are sending the instruction through the same path that the UI button would send it through. So you'll have the same process happening. Okay, so that should be everything that's needed on a UI front. Now, in order for us to actually do this properly, we need those valves to be off when the game loads. which means we need to work out why the chiller is not reporting its current volume properly if those valves are closed at the start of the game, because it's basically sitting here waiting for our output packet to be greater than 0, and it won't go ahead and start initializing the tanks or anything until it's confirmed that it has an output. So again, we need to work out what's going on with this. So we know that the pipe's going to be not reporting anything. So that's getting its value from the input manifold. Okay, so I think I know what's happening here. I think because we're not getting an input from anywhere, this is not actually firing. So where's our pipes there? So this fluid delivery that comes in, those are coming through on obviously on the 3 input paths. Now you'd expect this one to be receiving at least something, because that's the overflow from the actual tank. Because the tank's got fluid in it. I suppose it doesn't overflow until it's full. Yeah, so right, so what's happening is so we've set the tanks to be 10% full, which means any outgassing is just filling that void in the tank. We're not modeling pressure buildup from that outgassing unless the tank is full. So we're kind of making an assumption there. What we would need to do, realistically, is take the volume of the tank that has nothing in it, increase pressure for outgassing, because that cryogenic fluid is constantly in a state of cooling down. So as it returns to a gaseous state, that should be then going out of the overflow pipe back into the chiller and being recondensed into fluid and put back in the tank. So there's a constant loop going on there, but it's not kicking in unless the tank is full. So I think if we update the tank, because in a real one, then you'd have a pressure valve. So if the pressure was too high, then of course it would either do a seal break, so it would have one of those like seals that literally pop when the pressure is too high, or you'd have some kind of automated valve that opens and closes to relieve pressure, and that pressure goes into the chiller to be recondensed. So if we set our tank on our tank tick to do that, even if it's empty, so if relief flowing is true, yeah, so we are setting our current fill based on our boil off rates. So we should actually be sending it anyway. So relief flowing should be set anyway. Okay, so this is set based on the valve being open or closed. So if we set this to true as default, because we know the outflow valve is open by default, so that should start flowing. Because the way this works with the piped fluid simulation is we're sending messages back and forth along the pipe because we need to report pressure back up the pipe to the sender, and we need to know whether it's flowing. So if we close the relief valve, and the relief valve is obviously after the tank, so we need the tank to know, can it send fluid down the pipe, because it needs to know whether the valve is open. So when we close that valve, a message gets sent back up to the tank to say the valve's been closed. So like logically in the background, we now know we can't send anything through because of the blockage. By having this set to false as a default means that the tank cannot use the relief valve immediately. So that should hopefully fix the problem that stops the map from loading. Unreal does this thing. If you select multiple things with control held down, then sometimes it moves the object. Like that, it moved it because I selected that with control held down. If you do it with shift instead, that never happens. Yeah. And that was with control held down. Why does it do that? That's madness. Must remember to use shift. Right, so I want to close these valves on flight ready. And then hopefully that should then work. And then we will update these with a different flow rate. So these are our fake fluid refills. Right, so currently we're sending however many liters that is. Oh, and on that note, actually, we need to check the display on here. No, that's the wrong UI entirely. So fill level, we just need to know what math are we using for the conversion. That. Okay, so yeah, so current fill is in milliliters, so we just need to make sure on our engineering console, when we do our update, that we just need to multiply these values by 0.001 so that it's properly converted to liters. Hooray for metric. We shouldn't need anything else from that now. So yeah, so that would be 100 litres. I'll have to see. We'll see how quickly it fills up. I guess ideally we want it to refill in about 10 to 15 seconds. We'll see how that feels gameplay wise. And then let's just, again, we'll package it up because it's quicker and easier. Eventually, when the refueling mechanics are properly built in terms of gas giant skimming, you'll just have to be at a certain altitude, and we'll know what the density is at that altitude. So it's going to be altitude and density based, more than anything else. So it doesn't matter which way you're facing. Just making sure that you're the right altitude, the right density, and that should be sufficient for the gas scoop to work. There is a loop for the fuel system, so it sends a certain amount of litres per second to the reactor, and obviously the reactor is using a portion of that litres per second, and anything the reactor doesn't use gets fed back into the chiller and ultimately recooled and put back in the tank. So it is a circulatory system. So the reactor is only capable of using the maximum of what's in the pipe. So it's kind of sipping from the pipe as it goes through the system. If it uses the entirety of the fuel in the pipe, then obviously there's nothing left going back to the chiller. Yeah, if multiplayer has taught us anything, it's that a brig will always be needed. In fact, that's why we added it, because yeah, we had lots of people causing grief in multiplayer, as people would tend to do on the internet. So yeah, we always need to have those tools and systems in place to limit the amount of griefing that can be performed. Almost there. Four minutes and 27 seconds. Not terrible. let's see whether my assumption was correct or not. Not looking likely. I might need to force it to send something down the pipe so that the chiller initializes. I mean, I should be getting something from the tank, but then, well, of course. But then the tank is the next thing to be initialized. Okay. I think I know what's going on. So the tank, so the tank tick, where it starts sending out fluid, doesn't happen until after its initialization has been called. But of course, the chiller is waiting for something to come into it before it considered itself initialized. So I think what I'll do is, rather than waiting for this, because we know that the tank is going to be sending it, so we'll set up its state, start the tick running, and I think what we'll do is we'll skip this for now, and we'll just stick in a very simple 1 second delay, just to give like this a chance to set itself. We'll wait a second and then we'll initialize the tanks, simply because this fluid packet is not going to come from the tank until the tank ticks, and of course the tank is never going to tick because we initialize that here, and that relies on it. So we've got a loop which never completes. So that, I'm fairly confident we'll fix that. I'm going to put a note on there to remind myself of why I'm doing it. Right, yeah, so that should fix that. So I'm thinking we'll up the amount of refill by an additional 0, so that when we do hit the refill button, it should go quicker. And again, we will package because it is still quicker. This 4.5 minutes is still quicker than trying to load it in the engine. I could do illusion, yeah. I can't remember why I did the chillers first. I think it's because we wanted the tanks to start filling. But if we are now starting with the tanks full and the input valve is off for the refill, then yeah, it probably would make sense to initialize the tanks first. So I can definitely change that order around. And then that little workaround wouldn't be needed. Come on, CPU, you can do it. Thanks, Ben. Very much appreciated. We put a lot of effort into it. To say that this is our life is not an understatement. Like, literally, I went into the village with Claire today to have a cream tea, and the only thing we talked about while sat at the table drinking our cream teas and eating our scones was the game. Like, talking about the bug tracker and adding things to it, and literally it's all we ever talk about is the game. Yeah, Claire is my team. Now, our mods do a great job as well. They put a lot of effort in to help with the community, and yeah, that's hugely appreciated. So it's not just me. I mean, this is actually one of the things that I do discuss with Claire. Is like we've had a debate in the past about what constitutes as a solo developer, and it's one of those things like in the indie dev community where a true solo developer has to do literally everything. They have to do their own marketing, they have to do their own social media, they have to manage their own community, and the business side of things, and all of that doesn't involve making the game. Whereas, you know, I'm focusing on the game and Claire is doing everything else. So, you know, she takes care of the community, she does the advertising, she takes care of social media, she manages the emails, like she reminds me when I forget things. So, you know, I cannot class myself as a solo developer because without Claire doing the stuff that she does, I wouldn't have half the time needed to do the stuff I do. So, like, you're not truly a solo developer unless you're doing literally all of it yourself. And, you know, as a solo developer, you can only dev for half the time because the other half of the time, there's a lot of other stuff that needs doing. So we are, at minimum, a team of 2. And, you know, if we include all the mods and helpers on top of that, we are a team of a dozen or so. Yeah, Claire does all the boring stuff. Oh yeah, that's true actually. Yeah, Claire has planted all the flower beds in the game, so she does do some dev work. She can add developer to her title list. Community-wise, we have... Oh yeah, that did work. It worked without me realizing it worked. Yeah, community-wise, we've got over 10,000 people on Discord. We've got 18,000 odd subscribers on YouTube. We're up 160,000 wish lists now on Steam. So the numbers are good. You know, we're definitely going places with the community numbers. I do feel that we peaked a bit early because, you know, out of necessity, really, you know, we had to, we had to go public with the game. We had to announce. We had to start fundraising. If we had continued like in silence without building up a community, we wouldn't have had the support we needed to continue making the game. So, us announcing the game at such an early stage was literally driven by necessity. In an ideal world, I would have liked to have developed the game in complete silence for a good couple of years before going public with it. Because the problem we have now is, like, a lot of people saw the game over Kickstarter, and, you know, we were very much in pre-alpha, And we're still already in pre-alpha. It's still in pre-alpha. I'm not ready to call it alpha until we go to early access, because at that point all of our main gameplay pillars will be done, at least to a point. Stuff will still be grey boxed, but all of our main gameplay stuff will be into it to some extent. At that point, I'll be happy to class the game as an alpha product. But of course, it means the community that learned about the game, especially 2 years ago in Kickstarter, have had to sit around for 2 years, watching the game slowly be made. And we've probably got another year yet to go, having the game being made a little bit at a time. So yeah, it's difficult to keep that engagement going and keep the community excited because it is so slow making the game. And the things that we've gone public with are the sorts of things that in a normal studio that wouldn't have seen the light of day. Studios don't go public with projects until there's something really decent to show. So yeah, we have gone public too early in that regard. So I'm incredibly grateful that the community has stuck with us as long as they have, given how long it's taking to make the game. But yeah, we will continue to make the game, and we will continuing until it's done. Right, let's give this a try. So, open refill valve. Not seeing any action on the refill. Right, let's check down in the room. Right, okay, so they're still closed. Was it you? Did you do it? Oh, they're messing with my stuff. Shoo. Right, yeah, they're still closed. So that means that our button is not working. So that should absolutely be sending that signal to open the valve. Okay, so let's have a look at how quickly those tanks actually fill, because that was the other thing that we wanted to look at. Right, so there's our current volume. So if we open the helium valve, how quickly is it going to go up? Okay, I think that's... I'd say that was a reasonable refill speed. That's basically 1,000 litres a second. That's going to need fixing. So yeah, 1,000 litres per second coming from the refill. Which means, you're getting to see the visuals out the window. In fact, if I look at that on the bridge, that should match up. Yeah, maybe I'll oh no, watts per second seems to be good enough. I could always make this tick quicker if need be, but the pipes and everything work on a 1 second tick, so it's never going to go quicker than that. Okay, so the last piece of the puzzle then is just making these buttons work, and then we should be able to stop and start the refilling. Assuming close didn't work either. No. Okay. All right then. Okay, so the question then is why are those buttons not buttoning? Yeah, we'll fix the fonts. Yeah, I think 1,000 litres per second is significantly quick. But yeah, we'll see how that feels, because once you're actually in orbit around a gas giant and like you're cruising the cloud layers, then you know, it's going to be a different experience then, because there'll be visuals going on and you're not just staring at a UI for the most part anyway. Right, so we are sending that valve open, and we're sending it to the valve itself. So we're sending it to that. So we're going event fluid UI input. So fluid UI input widget. Fluid UI input widgets. Sending our button ID. So that's going through to the player controller for replication. Comes back replicated. And then we simply open or close our valve, doing all the usual stuff, flashing the buttons. So the question is, why is that not firing? I'm going to have to try and do this in the editor so that we can see our debug messaging. I'll just give it the button ID. Okay, so that's us sending it as a client, and that's it coming back as a server authoritative event. So we should see it green as the client, orange as the server, and that should just happen. Let's try running it standalone. Let's try running it there first, see how quickly it loads. Oh, that's not too bad actually. Running it from the editor window, it takes forever. I like how you can see like all the wall panels appearing as it's loading. What do we get? Okay, so basically we're getting nothing when we hit the button. That's interesting. What's also interesting is we don't have the lines on the UI. Oh, now we do. It must have just been a weird colour. Okay, yeah, so buttons doing nothing. That's not helpful to us at all. So that would mean, one would assume, that that we're not getting a reference to that actor. So, oh, I know why. It's because the class is not valve. This is one of those derp moments. Right, I was trying to get the wrong class. Now it'll work. And of course now it'll be wrong because all of these will be the wrong class. So these all need changing to valve. I need to go through a lot of the folders and the project folders and remove a bunch of these old blueprints, because I've got like things I downloaded yonks ago and they're just sat there in the project, and it's really increasing the overhead when it's trying to search for references on things. We're not using 1900 blueprints, I'm sure. Okay, and then I'll just refresh these. Don't worry, we'll get there. The nice thing at the moment is that we've completed a lot of the core system work. So what we're doing now is we're just building gameplay systems. So that's why we've been working on the bridge and adding the NPCs and getting them kind of prototyped. So everything really from this point is just building on those core systems and just rolling up the gameplay. So my goal for 2026 is just gameplay all the way. So just gameplay after gameplay, so that we can get all of our gameplay pillars done, hopefully before Christmas, so that we can then start thinking about a polished early access release. Because we can't go to early access until all the planned gameplay is at least playable to some extent. It doesn't need to be finished or polished, but just playable to some extent. So we can at least demonstrate the 8 different roles and have some role-based gameplay for those 8 different roles, in addition to the usual bits and pieces in the galaxy that will need to be there as well. Okay. Oh, there we go. That's working. So we can open the valves now, and they will start filling the tanks. And they're working independently too, which is nice. And if we then close those valves, they should stop refilling. Obviously they have to go through their cycling. Yep, there we go. So we could do with maybe a valve state, so we can see whether the valve is opened or closed. And I think what we'll do with the gas giant proximity check is we'll actually use these guys as our fuel scoop. So maybe we will use altitude as our metric. So the closer you get to the gas giant, the quicker that will go up. Here, let's just try something a minute. I'm conscious of time. Right, yeah. I'll try and do this really quick. So we want to get our event handler, the old one that we're going to remove, and then we want to bind global events by class, spelled correctly, and that is sector location details. Because what we're doing is when you enter a sector of a sector location, as in a subsector of a sector, it generates a star system and sends out that data. So we need that star system data available to us to know whether or not we are near a gas giant. So right, yeah, custom events. So entered new subsector. So we will cast to sector location details, and we will get that. We shall promote that to a variable. So now we have a captured copy of our sector location details, which is all our planets and stuff. Actually, to be honest with you, we probably don't even need the full thing. We only need satellite objects. Because ultimately we only care about the objects in the galaxy, so we don't need the whole thing. Objects in the system, rather. Yeah, so that's all the physical objects in the star system, and then for those, actually we'll leave that like that, which means we also need accept timer by function, which is get closest planet. And again, we'll do this on a 1 second loop. So once per second, we are going to try and find the closest planet to us. We seem to be doing this in a few different places now, so I think I might centralize this so that we're always broadcasting the closest object rather than having multiple systems look for it, because I'm sure we are wasting CPU time with that. So for each planet, we want to get our ship state, and this is an example of something which has been centralized, so we always know all of that about our ship at all times. We're dealing with local coordinates here, so we are going to grab our local coordinates, and we're going to measure distance to our ship. in our local coordinate space. Okay, so now we know how far this object is. So if we construct a duplicate of this, I suppose. Actually, no, we don't need to do that even. We can just get a reference to that using our array index. And then we need to set members, and we need to set our distance value like that. So we're using the array index here to get a settable version of the entry in there. So that should update this. So having done that, we can then order sort array by member name. Member name is distance, like that. So now we have our first object in the array being our closest object, so we can get the details of that object, and what we're most interested in is object type. So if we switch on that, oops, didn't want to drag the whole thing. So now we've got all the different gas giant classes along with everything else. So I can either do that from a switch, which is probably too many things, or we can do equals. I wonder whether there's an easier way. No, we'll do it like this. Yeah, so we need to go through all of our gas giant classes. So class 1, I got to do this one at a time. Class 2, class 3, class 4, class 5, and ice giant. I've got a better idea. If we promote that to a variable, then we call this closest object. Okay. Just think of the best way of doing this. So we also want to tick no, actually, we'll do it from this. We'll keep that stored as a variable, but we'll run it from this. Because what we want to do is we want to select on the type of object that we're dealing with. It is going to create a long list, but that's kind of unavoidable. So we're interested in that and our distance. Actually, we want that, we want the distance, and we want the radius. Because what we can do is we can change the refueling rate depending on class of object and how far away we are from the body radius. So let's just promote these a minute. So our distance from the gas, well, altitude rather, is distance minus the radius. So that's our altitude. I'll just do all this in line for now because we're rushing. Okay, so that's our altitude. So our refill rate. So if we make that refill rate, so that's our liters per second, basically. So our liters per second is going to be this as a float. Multiplied by a scalar which we'll determine from our altitude. So if we were to say, if we do map range clamped, so our distance is in centimeters, our body radius is in kilometers, so we need to convert that to centimeters to begin with, otherwise that will confuse matters. So we're just dealing with centimeters. So that's our altitude in centimeters. So then we want to work out how we're going to do the distance on that. So if I do length converter. Right, so what I want to work out is let's say from 1 kilometer above essentially the upper atmosphere of the gas giant. So the radius of a gas giant is kind of fuzzy because it's like where do you determine the radius, because it's made of gas. So let's just say 1 kilometer above the cloud deck, maybe. So obviously that's that many centimeters. So our range would be from there, in which case that's our maximum value. So our refill tick would be that. Yeah, so the true value is going to be our refill rate, which we will determine. So that should default to 0. So yeah, refill rate of 0 by default. So if we are literally skimming the surface of the gas giant, that is our maximum refill rate. Oh, actually no, sorry, that's my bad. We want to do this as a multiplier, don't we? So an ice giant, sorry, would be the maximum. And then as we go down through the types of gas giant, we can reduce the amount of fuel that you are receiving by temperature. So each class of gas giant is hotter than the one beforehand. So it means a class 5 gas giant is half as good as an ice giant in terms of fuel flow. And then we're multiplying this by 1, which is the maximum. So your maximum fuel fill is 1 kilometer above the surface of the gas giant. And then if we do that up to 100 kilometers above the atmosphere, which means you'll be quite close. Hang on, where's the length converter gone? So then 100 kilometers would be that many centimeters. Okay, so this is kind of rushed, but hopefully you can follow where I'm going with it. So these are the maximum refill rates from these particular types of gas giants, and then that's multiplied by a scalar here, depending on the altitude above said gas giant. So we are calculating the closest gas giant, well, the closest thing to us. If it's not a gas giant, then our refill rate is 0 because it's not a gas giant. If it is a gas giant, then obviously we give it a value, and then we multiply that by altitude, and that is our sum refill rate in liters per second. So now, if we try and refill, it should go up really slowly until we get near a gas giant. And to make that more interesting, very quickly, I'm going to see whether or not I can turn tessellation back on for the gas giants. Did I just load the wrong level? I think I did. Yeah, I did. I know. Don't know why I put the ship there. Okay. Right, planet. Wrong type of planet. Need a different planet. Okay, so let's make you a gas giant. Forgot I unified that under one system. Ice giant, there we go. Randomize. That's not an ice giant. I think we're off by 1 somewhere. You'll do though. So we want to essentially increase the tessellation on this so that we actually see 3D clouds as opposed to our standard flat texture. Can't remember where it is. There it is. Yeah, so I already had tessellation set up, so we can turn that back on. So enable tessellation, make sure it's 0 to 1. Center should be 0. Okay. So I'm basically kind of forcing a height map on this. It's a bodge, but it should give us some 3D terrain. Let me speed our camera up, if I can remember how these days. In 5.6, the camera controls got moved. There we go. I can never remember where they got moved to. Okay, so yeah, the flickering tells me that it's worked. Let's do a different type. Okay, so clearly that's not a gas giant, or is it? No, But that's what tessellation gives us. It gives us that kind of fake 3D terrain. So it's not true 3D terrain, but it's better than a flat texture. Oh, I see what it's doing. It's randomizing across all planet types. That is no good. We just want... Hang on, let me check my script a minute on that, because we don't want it to be making not gas giants. Let's force that to be ice giants only for now. There we go. Okay, so now we've still got a bit of weirdness, but you can see we now have clouds that are 3D and moving on the surface. Now the reason that it is so weird looking is because that's a bit too far. Gas giants are 1-to-1 scale, so we're tessellating something literally at gas giant planetary scales, so we do get some weirdness. This used to crash the engine. Well done Epic for fixing this, because now it's completely stable. Stable, if a bit glitchy. But yeah, the idea was to just to give them a little bit of surface. But I guess we don't really want the ship like hitting the atmosphere cutoff either. So we're going to need to limit the ship altitude to kind of there. So we need to work out like where that is altitude wise. Let's mess with this a minute. See if we can't increase the details a bit without losing some definition. Because anywhere that has kind of big dark patches should have a lot of like depth associated with it. Let's put that back in the middle. Yeah, it's definitely not happy with that. What if we do it top down? It should technically just be flat. Yeah, so 0 is the best we're going to be able to do. And this is new. I don't remember seeing this before. I shall have to experiment with that. But yeah, the nice thing about doing it with tessellation as well is that obviously the clouds are animated, so you actually get to see like 3D animated clouds as well. If only we can like fix what is probably a floating point issue because of the extreme sizes involved. And I don't think this value is going to be helpful to us. helped a little bit. Yeah, obviously once we make these volumetric properly, then we won't have any issues like this, because it will just be a volumetric object, and then we'll add detail the closer you get. It's a shame that this is so glitchy with tessellation, because that would have been a decent compromise as an interim thing. But I think the glitchiness of it is just going to look weird when you get down low, which is a shame. Yeah, because places like storms like this would look quite cool flying over it low. Okay, so we will not enable tessellation for now. I'll see if I can clean it up at all, but I don't think nanite tessellation is ready for planet scaled objects yet. Right, so the last thing then, before we go, I will add a debug to this, so that we can get an idea of our altitude. In fact, let's type that in so that I remember what the number was representing. Again, that's going to be in centimeters. So if we do centimeters to kilometers and give it a kilometer value, and stick kilometers in there, pop that in there. It can stay for a second. We'll make it yellow. Yeah, so if we now load this up and fly to a gas giants, we'll see what we're looking at in terms of our kilometer distance from the surface, because at least for testing we don't want to get the ship down too low, because I think that's going to ultimately cause more problems than is needed. Oh yeah, wrong level. Mars SARS. That sounds nasty. You're welcome, Frusters. It is a pleasure, as always. That just sounds painful. So our altitude value is good, so that's how far we are from Earth right now. So that should be reading reasonably correct. I mean, it looks about 1400 kilometers away. So if we go to Jupiter, let's fix fix all that a minute. Okay, so our altitude value is going to continually go up until we start approaching a planet, and then it should start going down again, which it is doing, so that's good. I'm pretty sure this was Jupiter. Oh no, I misjudged that, but still, it's a gas giant, it works. So right now, obviously we should have no refueling ability at all, so our refill rate should be 0, which it is. Okay, we're 13,000. Yeah, we're 13,000 kilometers away, and I guess we need to see what 100 kilometers looks like at these distances. So we're still 1,400 kilometers away. Gas giants are quite big. Still 500,000 kilometers away. No, sorry, 500 kilometers, not 500,000. Okay, 250, 200. Right, so okay, if we just stop there a second, 110. So 110 kilometers above the surface, we shouldn't be seeing any refill at all, which we're not, so that's good. So as we get closer, so let's just speed up. Okay, so we should be filling at roughly half our target speed. Yeah, so it's definitely going up. Okay. Oh, we've gone too far. That grey mess underneath the surface, by the way, is the shadow caster. So it's the thing that's casting shadows from the gas giant onto other objects, and similarly like from inside moons and stuff. Okay, so we're now -1 kilometer. So when it comes to the future of this, when this is a volumetric gas giant, I guess this is going to be the upper cloud deck. So everything below us right now is going to be a swirling mass of clouds. So that's what we need to plow into in order to start refueling. But in the absence of that, at the moment. I think we're going to have to make it a lot more lenient, and we'll just have it as being maybe double the radius of the gas giant. Oh, get out the chair. Yeah, so we're now filling up full speed. Okay, so the distance-based refueling speeds is working. The refueling speed per type of gas giant is working, and the ability to open and close the valves is working. Let's just go ahead and close those, and they should stop refilling, which they have. And then we open them again, and they should start refilling. Okay, so that's all working as intended. Yeah, so I think until we've got better looking gas giants up close and the ability for the autopilot to do like proper gas giant skimming, I think we'll be really generous with how close you can be. So for that we're going to need, if we do, well, let's base it on radius actually. So where is that? Okay, so we've got our radius there. So our minimum is going to be body radius in centimeters multiplied by 1.5. Yeah, so that's our like maximum refueling speed. That's basically kind of the same distance that autopilot drops you off anyway. And that will reduce to 0 if you exceed, I guess, twice the radius of the gas giant. So yeah, so until we've got close approaches that are better and better looking, we'll do it like this. So 1.5 times the radius for our maximum refill distance. Anything over twice the radius, you'll get zip. Actually, we could probably let's middle ground that. Actually, let's do 1.75 where it will cut off completely, and 1.25 for maximum fuel refill, because the autopilot drops you off in the middle of these two values. So if you manually fly the ship closer, you'll get more bang for the buck. And of course, these can stay as they are. So different types of gas giant give you different fuel values. Although maybe we can cut these down a bit more significantly. So like 1, 2, 5, 8, 9. Yeah. So class 4 and 5 are too hot, and everything above that is good for scooping. Okay. Oh, I forgot my camera was all like set too fast. I think that's it actually. Let's just do one last test just to make sure it's working, and then I shall put this out as a build probably tomorrow. At this point, I'll do a bit more tidying up first with it, and then yeah, it can go out tomorrow as a build that you guys can test. I think before I put it out as a build as well, I'll add some kind of audible alert to let you know that the fuel is running out. Maybe some kind of like light that flashes on the engineering console. Yeah, exactly that, Melissa. So if the ship is running low on fuel, then I need to input the red line. So I'll put it at, say, 5%. So if you've got 5% fuel remaining, then some kind of red light will flash above that console, so that you can visually see that, hang on a minute, something's flashing, I'd better go and have a look. Forgot how doors work. Yeah, so if we just go to Uranus again, I think that was. Mars, Ceres, Jupiter, Saturn. Yeah. Go to Saturn. Okay, so if I open all 3 refill valves now, and I guess we need a flow rate on here as well, so we can see the current flow rate. That would be handy. So right now, we're not seeing anything. And then as we approach, we should see that flow rate go up. Okay, so nothing yet. Still approaching. Still approaching, haven't quite got there yet. Okay. Yeah, so they're not filling. So we should be close enough, because we are about 1.5 the radius as our target stop location. But I'll debug that and we'll find out what's going on. But this distance when you stop should be about 50% efficiency on the fuel refill. And if you decide to get closer, then it should go up to the full amount. But obviously I'll fix that before I put the dev build out. And I'll add a flow rate as well, so you can actually see. Maybe if I add an efficiency thing on there as well, so you can see the current flow rate and the scoop efficiency, so you can tell whether you're close enough for maximum efficiency. I guess that would be useful. Okay, we shall leave it there. God, there's me not paying attention and Claire's doing Gandalf impersonations. Yes, Ranza, the usage is actually quite low. So yeah, but actually, to be honest, saying that, the usage also needs to go up so that it will drain the tanks after 100 light years going full throttle. But I'll work out the math on that, so it's reasonably consistent. And it was good to have you as well, Zephyr. Right, have a good one, everyone. I now need to go and put the bins out because it's bin day for us. So that's the exciting things that I get to do after a stream. And then I might be allowed to sit down with a cup of tea after that. All right, have a good one, and I shall see you on Friday. Have a good rest of the week. Bye for now.